let's see how long your short-term memory lasts, right? So because the ordered pair 2, 3 satisfy both equations, it is a blank of the system of equations. What should I put in here to fill in the answer? No, consistent depend shows you what kind of system equations. What is it? It's a solution. Solution. So a solution to the system equations is something that satisfies both of them. In fact, what you could do if you wanted to would be to take this point here, 8 and 4, and plug it into both equations and see that it works. Likewise, you could take the point 10 and 800 and put it in here, and again find that it works in both of them. So that's our solution to our system equations. So to kind of reinforce on that and dovetail on that, how many ordered pairs satisfy this system of equations? So actually that would be this one right here. So let me do this. How many ordered pairs do you think, how many pairs of numbers satisfy that equation?
Infinite.
An infinite number, yeah. Infinite. And infinite. How about the other one? How many satisfy this one? Again, an infinite number. All right. So, infinite. But how many satisfy both of them? So that's the big thing there. How many satisfy both equations at the same time? One. Exactly. So one point, and that point, that solution is 0, 3. Make sure that you realize that your solutions to these types of problems have an x and a y coordinate. Don't just stop by giving me one of them, give me two of them. So there's a few ways that we're going to solve systems of equations. One of them we've already done. We've done it by graphing. But what else can we do? Well, there's what's sometimes called the elimination method. I prefer to call it the addition method. But let's start moving into that this way. It says, what constant should each equation be multiplied if the terms of x are to drop out? Well, let's see. What would you add to the 2 here? What do you add to 2 to make it equal to 0? Negative 2. So if I multiply this equation, say, by negative 2, that's going to give me negative 2x plus 2y equals actually positive 2. And I could add that to the second equation here, 2x minus y equals 1. And what do I get? What happens when I add those together?
Y equals 3.
Yeah. Actually, yeah, exactly it. Y equals 3. 2y minus y gives me a y, and then 3 on the right-hand side. The x's cancel each other out, so y equals 3. Great. That's half of our solution. Let's see if we can't find the other half. What would you think we can do to find the other half?
Plug in y.
Yeah, plug in y. You could plug in y into either of these two equations. It'll work fine either way. So let's plug it into the top equation. X minus 3 equals negative 1. If you add 3 to both sides, we'll end up with x equals 2. When you put your answer into WebAssign, make sure you answer as an ordered pair. I'm sure that's what they're going to be asking for. So it'd be 2, 3 would be your final answer there. And so we solve this by the addition method. So, addition method. Now there's a lot of problems you can solve by the addition method. We're also going to learn something called substitution. So let's move on down to example D and work with a few problems there. So there's a kind of an increasing level of difficulty here. Example D. 8x minus 2y equals 26. And 4x minus 13 equals y. So there's a little bit of a twist right here at the start. And that is, I don't have everything lined up the way I did in the previous problem. In the previous problem, I had x's and y's. They're all looking good because they were lined up pretty nice. So let me move the y to this side and the 13 to the other side. So I'm going to leave the first equation alone. 8x minus 2y equals 26. But when something changes sides, what else changes in it? Signs. Good. So what's our new equation here?
4x minus y equals 18.
Nice. Now, in solving our system of equations, what we generally like to do is try and get rid of one of the variables. In the previous system of equations, we got rid of the x's. You could get rid of the y's or the x's. But to do that, I'm going to multiply one set of equations by something. If I wanted to get rid of the x's, what would I add to 8x to cancel it out? Negative 8. So what would I multiply this by then to get that negative 8? Negative 2. So if I multiply that by negative 2, I end up with negative 8x plus 2y equals negative 26. And then 8x minus 2y equals 26. I'll let you play with that while I graph it. But see if you can't make sense out of what we end up with. Let's try this one. Nope, wrong one. Okay. All right. Regardless, let's see. No, these are the wrong ones. So let's just do a new graph. So what did you find out when you tried to add these together? What did you end up with? Is that 0? 0 equals 0. Well, that's kind of bizarre. Can anyone make sense out of what's going on here? Well, tell you what, let's graph both equations then. We've got 8x minus 4y equals 26. So I'll graph that one in red. Now, if you're graphing this on a graphing calculator, you're kind of handicapped a little bit because you have to solve for y. I mean, you could solve for y in that one. It'd be y equals 26 minus 8x. Or no, actually, the other way around. 8x minus 26. And then the whole thing divided by 4. And if you notice, both of those graphs, let me just turn off one and the other. Both of those graphs are the same. Yeah. So if you're trying to do this on your graphing calculator, just keep in mind that you have to solve for y. Let's take a look at our other equation, 4x minus 13 equals y. Something looks wrong. What did I do wrong here? What's wrong with this equation?
The first one is 2y, yeah.
Oh, 2y. 2y, thank you. 2y. So that'd be a 2 here. There we go. Everything's the same now. So let's shut this one off. But notice that these two lines are really the same, right? That's why we're getting this strange solution. So those two are the same. That's wonderful. Let's do this. Let's have a little fun here. Yay. But the thing is that this is a true statement. And if it's true and you end up with something like this where the variable's dropped out, that's telling you you have a dependent system. Keep in mind that this is true. Even though it's kind of trivial, 0 does equal 0. It's like, yeah, okay, not telling me anything really earth-shattering there. It's true. And so this is reflecting the geometry of the situation, that the two lines are really one on top of the other. Let's try another one. Let's try the next one in line here, which is 2x plus 4y equals 17, and x equals 2 times 4 minus y. Okay. Well, it might be nice to get this all lined up like we did the last one, which is, say, want the x's and y's together on the left-hand side. So to do that, I'm going to keep the top equation the same, but the bottom equation, I'm going to distribute the 2 and get x equals, let's see, 8 minus 2y. Still not there yet. So the last thing I need to do is I need to move the 2y to the left-hand side. Manny, what would I get when I move that y to the left-hand side, that y term?
Y equals, or 2y, negative 2y.
Well, when a term changes sides, what else changes?
Oh, the sign.
So what would I get? X plus 2y equals 8. Nice. Okay. That's fine. But I want to solve this here. So in the first couple of problems, we've gotten rid of the x's. Let's for a change get rid of the y's. If I wanted to get rid of the y's here, what would I multiply multiply the bottom equation by? Negative 2. So I'll multiply this by negative 2. The top equation is going to stay the same. I'm going to have 2x plus 4y equals 17. The bottom equation, Bahra, can you tell me what the bottom equation is going to become?
Negative 2x minus 4y equals negative 16.
Perfect, perfect. Pfeiffer, when I add these two equations together, what do I get? 0 equals 1. So again, all our variables are dropping out. That's kind of a bummer. But that is kind of bizarre. 0 equals 1. What do you think's going on? It's false. Yeah, it is false. But what does it reflect about our system of equations? Remember, there was 3 different things that can happen when you're looking at a system of equations. So qualitatively, it's one of these 3. Tell you what, I'll rule out this one because we didn't get any numbers. Which one do you think it is?
It's going to be the second one.
Yes. So if you get something which is false, when you solve and all the variables have dropped out, if you get something which is false, that's going to be something like this, an inconsistent independent system. The two lines are essentially parallel. That's what's going on. So inconsistent, independent. It's independent because the two lines are different. It's inconsistent because there's no solution. Nice. Let's keep rolling. Let's move on down to the next one here, which is this one. 0.3a plus 0.1b equals 1.9. 4/3 a plus 1/3 b equals 9. Now, most of you would probably be less than enthusiastic to see a problem like this on an exam. Can someone put into words for me what just doesn't look that fun or appetizing about this problem? Decimals, yes. It's got decimals. And it's even got fractions, right? It's got the worst of both worlds.
Change the decimals to fractions.
We could do that. But the overall goal, I think, is to just get rid of them, right?
Oh.
Not have to deal with any of those things. So, can anyone think of anything I can do to get rid of the decimals here, other than just changing them to fractions, which is kind of just reshaping the problem, but not getting rid of the root of the problem? Kez?
Is it multiply by 10?
Yeah, multiply by 10. Multiplying by 10 is going to move the decimal place 1 to the right, and that's as far as we need to move it, right? It's going to get rid of that decimal. If I had 2 decimal places to get rid of, then I'd multiply by 100, and so on. So, Gavin, what equation do I get if I multiply this by 10, please? All right, 3a plus 1b equals 19. I'm not going to write the 1b. I'm just going to write, b. But you're more than happy to write 1b. Let's keep going. So we're much happier with that first one. How about the second one? Madison, what can we multiply by this time?
Both of them has to down their threes, so you can just multiply with.
We're going to multiply everything by 3. Now, I didn't exactly show it, but that 10 in the first problem has to distribute itself to all 3 terms. Same thing with the 3 in this problem. It's going to distribute itself to all 3 terms. Here, here, and here. Even though the 9 doesn't have a fraction, it still gets multiplied by 3. So I'll do that one for you. That's going to be 27. Yeah, and let's just take kind of a look here. 3 times 4/3 is the same as 3 over 1 times 4 over 3. And I really hope that you would cancel out the 3's here and just get 4. So 4a plus what? Plus b equals 27. Let's keep it going with the addition method. If you wanted to, you could multiply the top equation by, say, 4 and the bottom equation by -3, and these two leading coefficients would both be 12 and -12. They would cancel each other out. Is there an easier way that I could do this? Something, what would it be?
-1.
Yeah, let's multiply one of these equations by -1. I'm just going to choose the bottom one. So if we multiply that by -1, let's bring things down here. I'll have 3a plus b equals 19, minus 4a minus b equals -27. Stephanie, what equation does it give me when I add these two together? Yeah, -1a equals -8. If you divide both sides by -1, we end up with a equals 8. Thank you, Stephanie. All right, so a equals 8. 1 down, 1 to go. Josh, how am I going to find what b is? I know what a is. How am I going to find b?
You plug in any of the equations?
Yeah, you plug into a in any of the equations. It could be this one, this one, this one, this one. Any of those 4. Personally, I would pick one of these. I mean, technically, I guess you should probably put it back in the original one, but that looks like it's a little bit more work than most people are going to do. So let's plug it in this one. 3 times 8 plus b equals 19. So it's going to be 24 plus b equals 19. B equals negative 5. Great. Mowing them down like the Lions mowed down the Jaguars yesterday.
Over 50 points.
Yep. Pretty nice, pretty nice.
Once again. That's really nice.
Let me follow this up with a question here. Iris, is this system of equations consistent or inconsistent?
It's interesting.
Consistent, nice. Now we don't have the graph here, we can't see that, but we found a solution, so it's consistent. Consistent. Thank you, Iris. And Mackenzie, is this system of equations dependent or independent?
Dependent?
Are they the same line? No, they're different lines. That's why we found a solution, because we found one place where they intersect. So you can't have this, because our variables would have dropped out. Can't be this, because we would have had an 0 equals 1 kind of thing. We end up with this. The lines cross each other. We found one solution. It's a consistent, independent system of equations. A lot of people overlook this vocabulary. It's something I do want you to know, and it should be a couple easy points on an exam. So please do kind of pay attention to it. Comments or thoughts on this one? Are we looking okay here? I'm looking to see if I want to do this next one, or if I want to start jumping down over to here. Let's move down to this one. You know what? We should probably do this one first. Let's do that one. All right, so 2 times 2x plus 3y equals 5. 8x equals 3 times 1 plus 3y. How would you start? What would you suggest we do to get started on this one?
Distribute.
Yeah, distribute. So that's going to be 4x plus 6y equals 5. And then over here I've got 8x equals 3 plus 9y. That's looking better, but Alex, I need to get this thing all straightened out. What do you think I'll be doing with the second equation to try and clean this up a little bit?
Moving a 3 to the left, and then moving the 9 to the left.
All right, so let's move that 9y to the left-hand side. Thank you. Kiana, what equation do I get when I move that 9y? Thank you. Thank you both. 8x minus 9y equals 3. All right, looking good. There's a couple ways you can get a variable to drop out. If I wanted to get rid of the x's, that's probably the easiest thing. What would I do to get rid of the x's?
Multiply -2 is the first equation.
Kaz, rocking on these things. Yeah, multiply the top equation by -2. That would work. What if I wanted to get rid of the y's? Can anyone see a way to get rid of the y's?
Multiply the bottom by 2 and the top by 3.
Yeah, nice. So the lowest common multiple for these things would be 18. So to get an 18 for the y's up here, you can multiply that by 3. multiply by 2 here, and these would both be 18, except this would be a negative 18. So to me, it seems like the easier thing to do is just multiply once, multiply by negative 2. But keep in mind that sometimes you're going to need to multiply both equations in order to get a couple variables to cancel each other out. So let's multiply that top one by negative 2. And I'll get negative 8x minus 12y equals negative 10. And then 8x minus 9y equals 3. Okay, looking good. Josh, what do I get when I combine the two equations?
Negative 21y equals negative 7.
Awesome, awesome. Now this is the tricky part. Is the answer here y equals 3? I got a no and a yes. I need a deciding vote. So let's just be careful. What do we have to do to solve here? Divide by negative 21. So it's going to be y.
Negative 1/3.
Well, the negatives cancel each other out, right? So 7 divided by 21 is actually 1/3. It's very easy to kind of blow by this and end up with y equals 3. I see it happen all the time. So y equals 3, great, that's half of our solution. Please don't forget to give me x and y, or a and b, or r and s, t and u, whatever the variables are. I need to go back and figure out how to solve, or what x is. Carl, suggestions. How can I figure out what x is?
Plug y in.
Yeah, plug y in. Which equation do you want to plug y in? This one, this one, this one, or this one? So I'll number them. 1, 2, 3, or 4. Which one looks good?
Do 3.
Do 3? I like 3. Let's plug it into 3. So we've got 4x plus 6y equals 5. Let's plug in that 3. Four x plus 6 times 1/3 equals 5. 4x plus 2 equals 5. 4x equals 3. What does x equal? 3/4. Nice. So there's your solution. WebAssign would probably ask that you put it in the form of 3/4 and 1/3, x and y. They're always going to be in alphabetical order. Sometimes they have other variables, C and D, A and B, etc., but they always go in alphabetical order. All right, good one. Glad we took the time to do that one.
And also business.
On a roll this weekend. Okay, let's do a few more here. Let's move on to example E. And I'm going to show you another trick in solving these systems of equations. So example E looks like this: 30x minus 3y equals 15, and 10x minus 5 equals y. Okay, looking good here. There's probably a couple things you can do and say about this problem, but let me start with the point that I want to get to. There's another way you can solve this system of equations. So we start out with the addition method, but you can also solve things by substitution. Substitution. And the substitution method works really well, especially for a problem like this, when you've already got y, or one of the variables, in this case y, by itself. Y is equal to this, so these two things are interchangeable. I can take this expression from the second equation and plug it into here, into the first equation. So let's do that. 30x minus 3 times something equals 15. That something is the expression for y. So I'm just going to put in a 10x minus 5 here, and let's see what happens. What should I do next? Manny? Yeah, thank you. Distribute. 30x minus 30x plus 15 equals 15. George, is there any simplification I can do here? What's 30 minus 30? No.
0.
It's just 0, right? They cancel each other out. So what's left for our equation then? 15 equals 15. Is 15 equals 15 true?
Yes.
So what's that telling me about my system of equations? Yeah, this is dependent. You guys are rocking this morning. Good job. It's a dependent system of equations. There's an infinite number of solutions. Now there is a little bit more work that you can do with it, but that's not going to be until you get to college algebra. So for right now, it's just good enough to know that there's a dependent system of equations. There's another one that solves pretty nicely here, and that's the last one. Before I get to that last one, are we okay with this one? Charlie?
Do you have an easier way to remember what dependent and consistent means? Mnemonic or something?
That's a great question. The answer is no, I don't. Although, you know, one thing I've always said to myself in terms of dependent is that because these two equations are the same, the solutions for one depend on the solutions for the other. So that's kind of my own little mnemonic for that. Consistent and inconsistent. I guess consistent feels more of a compliment and what you would want to happen. And a consistency equation is what we want. We're looking for where these cross each other. So, yeah, I wish I had something better. If you come up with something better, let me know. Share it with me. So let's look at the last of these here. Y equals negative 0.55x plus 3. And y equals 8.05x minus 12.7. Now, I'm going to rewrite this a little bit. I'm going to keep the top equation the same. But the bottom equation, I'm going to put more in slope-intercept. Well, I guess it already is in slope-intercept form, isn't it? Yeah, never mind. My bad. 8.05x minus 12.7. So I just copied this twice for myself. Good. Yeah, I know. It's all that fresh air we had during our fire drill. Can anyone tell me why this has to have a solution? And you have to think geometrically about this. And keep in mind that this is in slope-intercept form. Y equals mx plus b. I mean, just looking at this, I know it has to have a solution. But why am I right?
Because there's 2 y's.
Well, there's 2 lines. But under what circumstances are you not going to get a solution? What's the only case where there's no solution? What happens? If they're parallel. What do you know about the slopes of parallel lines? They're the same. Do these 2 lines have the same slope? No. So they have to cross. There has to be a solution there. Now, this is set up wonderfully for substitution, right? Because you got y here, and you can easily substitute into y down here. Kev's not looking impressed. It's like, really? Yeah. So we're going to take this expression here and plug it into that y over there. So it's going to be negative 0.55x plus 3 equals 8.05x minus 12.7. Now, Kez is still underwhelmed with this problem because he doesn't really like decimals that much. So what can I do here to get rid of the decimals?
Multiply by 100.
Yeah, well done. So we're going to multiply by 100 this time. Multiply by 100. And we'll end up with negative 55x plus 300 equals 805x minus, what am I going to subtract? What's that last one? 1270. Well done. Well done. All right, so let's play with this a little bit further. Now, for myself, because the 805 is bigger than this, I'm going to move the x's to the right-hand side. So I'll add 55x to both sides. Let's do that here. 55x, 55x. And then because I've got the x's on this side, I want to put the constants on the other side. So I'll add 1270 to both sides. Nice. So let's see what that gives me. Should be a nice simplification of this problem. I'll end up with 1570 equals 860x. How would I solve? Yeah, just divide both sides by 1860. 1570 over 860. You know, I'm not sure what that is in lowest terms. There is kind of a nice little way you can kind of figure that out, especially if you have a graphing calculator or Desmos handy. And I'm not really sure that having this in lowest terms is really going to be my biggest concern on this problem. So 1570 divided by 860. Now, at the very least, I guess I'd expect that you simplify the tens. You could just write 157 over 86.
Yeah, that's what it.
Is that what it ultimately turns into? When you press the enter key, you get this ugly decimal value, but the trick is hit the math key and press enter twice. And there you go. So it simplifies down to 157 over 86. Thank you, Charlie. That's our value for x. How are we going to get our value for y?
Plug X in.
Yeah, plug x in. Doesn't matter which one of these we plug it into. We should get the same thing. So I'm going to use the fact that I've already got this number here this way. I'm going to plug it into, I'll plug it into the second equation here, like this. Keep in mind that the answer that I already have is right here. So let's take 8.05 times my previous answer. Now that previous answer can be accessed right here, right above the opposite key. If you hit the second key, then the opposite key, this is essentially typing in 157 divided by 86 minus 12.7, and bam. Let's see. Let's get a nice decimal for that too, or fraction for that. Oof, ugly. I promise to give you better numbers than that. Y equals 3,433 divided by 1270. Yeesh, kind of ugly, but that's our answer. How are we looking on that one? Okay. Last minute thoughts, comments, questions, etc. So your answer that you would put into WebAssign would be 157 over 86, and then 3433 over 1270. By the way, Mackenzie, is this system of equations consistent or inconsistent? Good. Why? Okay, good guess. Why is it consistent, Charlie?
Because the lines aren't parallel with the slope.
Yeah, the lines aren't parallel, so they cross each other. And we found a solution, right? Consistent means you can find a solution. There's at least one solution, so it is consistent. It can't be dependent. To be dependent, they'd have to be the same line, right? And because they have different slopes and different intercepts, they're not the same line. So it has to be independent. Please don't overlook this last little bit here where we talk about consistent and inconsistent. Understand what's going on there, because it should be some easy points on an exam. You know, I'll give you a system of equations already graphed, and I'll ask you, is it consistent or inconsistent, dependent or independent? And if it's consistent, what's the solution? So nothing more than what we have here. Should be able to carve out a few easy points for yourself. All right, great. Let's put this one to rest.